If you have blue eyes, you are carrying something almost no one else on Earth shares. Fewer than 1 in 12 people alive have them. And here is the strange part. Every single one of those people, from a fishing village in Norway to a mountain valley in Afghanistan to a street corner in Buenos Aires, is linked by something invisible. They all carry the exact same tiny change in the exact same place in their DNA, down to the same single letter. Not a similar one, the same one. For most of the last century, we thought we knew where blue eyes came from. The answer seemed obvious. You could read it off any map of where blue eyes are common today. The far north of Europe, where half the population or more looks out at the world through pale eyes. So that, surely, was where it started. The cold, dim forests of the north. But when scientists finally followed the mutation back to its source, the trail did not end where anyone expected. It led somewhere older and stranger, and it began on the face of a person who looked nothing like the picture in your head. Before we follow that trail, if the hidden history written inside the human body is the kind of thing you find fascinating, take a second to subscribe. This is the sort of story that gets flattened into a single line in a textbook, and it deserves far more than that. Subscribe, turn on the bell, and let's keep going. Here is the first thing that will bother you once you know it. Your blue eyes are not blue. There is no blue pigment anywhere in a human iris. None. If you could take a blue eye and grind it down molecule by molecule, searching for a fleck of blue dye, you would never find one. It simply is not there. What you are looking at when you look into a pair of blue eyes is not color at all. It is light. The front of the iris is a thin, almost translucent tissue, and behind it sits a darker layer. When light passes into that front layer, it scatters. The longer wavelengths, the reds, the warm yellows, slip through and get absorbed by the dark backing behind. But the shorter, bluer wavelengths bounce back out toward whoever is looking. It is the exact same trick of physics that makes the daytime sky look blue, even though there is nothing blue in the air above you. The name for it is Tyndall scattering, and it is the only reason blue eyes exist. So a blue-eyed person is not showing you a blue substance. They are showing you scattered light. Every blue eye on this planet is, in a very real sense, carrying around a small fragment of the sky. And that changes the question entirely. Because if blue eyes are simply what happens when there is very little pigment in the iris, you might expect them to pop up randomly all over the world, anywhere a child happened to be born with low melanin. But that is not what the genetics show, not even close. In 2008, a team of researchers at the University of Copenhagen, led by a geneticist named Hans Eiberg, published a study that quietly rearranged our understanding of human ancestry. They had been chasing the origin of blue eyes for more than a decade. They gathered DNA from blue-eyed people across a wide sweep of countries and compared it, letter by letter, hunting for the one place where blue-eyed people differed from brown-eyed people. The human genome is around 3 billion of those letters long, an almost unimaginably vast instruction manual. And when they finally narrowed in on the region that governs eye color, the difference came down to a change so small you could miss it in a blink. It sat in a stretch of DNA called HERC2, in a narrow window just 166,000 letters wide, right beside a gene called OSA2. And here is what made the finding extraordinary. Every blue-eyed person they tested carried the same change, in the same spot, altered in the same way, down to the same single letter of code. A marker geneticists label RS12913832. Not similar changes, the same one. And there is really only one explanation for that. When a genetic change appears independently in different places, it almost always looks a little different each time, because random mutation rarely lands on the exact same letter twice. But when the change is identical everywhere you look, right down to the individual letter, the only sensible conclusion left is that it happened once, in one person. And everyone who now carries it inherited it from that single individual. That is the fingerprint of a common ancestor. One person, one moment, one tiny copying error somewhere between 6 and 10,000 years ago, echoing down through hundreds of generations until it reached the face you see in the mirror. We will never know that person's name. We will never know if they were a man or a woman, whether their strange pale eyes were admired or feared by the people around them. They left behind no monument, no writing, nothing at all, except a whisper in the genetic code that outlived every empire that came after them. But we know this much: they survived, they grew up, they had children, and the change they carried did not vanish. To understand how, we need to look at the gene itself. OCA2 is the gene that tells the iris how much melanin to make, melanin being the same brown-black pigment that colors your skin and your hair. Normally, OCA2 produces a healthy dose of brown pigment, and the eye comes out brown. But right next to it, in that HERC2 region, sits a kind of switch. The switch does not make pigment. It simply controls how loudly OCA2 is allowed to work, turning the melanin factory up or down. In the original mutation, that switch got turned down. Not off, down. Just enough to drain most of the brown out of the iris and let the light scatter through into blue. That is the whole of it. A dimmer nudged a fraction lower, one time, in one child thousands of years ago. And this is why the study landed the way it did. Because the finding was not really about eye color. It was about the fact that a feature we treat as ordinary, as something you might share with a neighbor or a stranger on a bus, is actually a thread that ties millions of unrelated-seeming people back to a single human being. So the obvious next question is the one the Copenhagen team could not answer with living DNA alone. Who was that person? And where did they live? For a long time, the assumption was that they must have lived somewhere in Northern Europe. That is where blue eyes cluster most heavily now. Estonia, Finland, Denmark, Iceland, whole countries where pale eyes are the norm rather than the exception. It seemed almost self-evident that the mutation had arisen there, in the cold northern forests, and spread out from that heartland. But ancient DNA told a different story. When researchers began pulling readable genetic code out of prehistoric skeletons, the earliest carriers of the blue eye switch did not turn up in Scandinavia at all. One of the clearest came from a cave in northern Spain, a hunter-gatherer who lived around 7,000 years ago, known to the researchers who sequenced him in 2014 as Braña 1. When Carlos Laueza Fox and his colleagues read his genome and published it in Nature, they found something that broke the picture almost everyone had been carrying in their heads. He had blue eyes, and he had dark skin. Not olive, not tanned, genuinely dark, closer to the skin of a person from sub-Saharan Africa than to any modern European. He lived in Europe, but he did not look the way we imagine ancient Europeans looked. His startlingly blue eyes sat in a dark face, and that combination, which feels almost impossible against the stereotype, was the original. That was how blue eyes first appeared on Earth. A few years later, the same shock arrived in Britain. A skeleton called Cheddar Man, who lived in what is now southwest England around 10,000 years ago, had his DNA sequenced and his face reconstructed. The team behind it, working with the Natural History Museum, found the same startling mix: dark skin, dark curled hair, and pale eyes. The image, when it was unveiled in 2018, quietly dismantled a very old assumption. The first blue-eyed people were not the blonde, pale ancestors of a northern master stock. They were dark-skinned hunter-gatherers whose ancestors had come from further east, out toward the deep interior of Eurasia. This matters more than it might seem, because blue eyes are a feature that has been dressed up again and again as a badge, a marker of some pure northern lineage, held up as if it were a certificate of belonging. The DNA takes that idea apart at the root. The people in whom blue eyes first appeared had skin as dark as the very people that mythology tried to rank beneath them. The trait and the myth were never connected at all. One is biology. The other is something people invented thousands of years too late. So where did the trail actually begin? Follow the earliest skeletons back, and they point not to the north, but toward the grasslands that run from the shores of the Black Sea eastward. The great open steppe stretching across what is now Ukraine and southern Russia and out toward Central Asia. This is the world the blue eye mutation seems to come from. Mobile bands of hunter-gatherers and later herders moving across an enormous grassland that belonged to neither Europe nor Asia as we draw those lines today. It sat between them, older than both. And once it was there, it began to move. This is where a single accident became a continent-wide inheritance. Around 5,000 years ago, a people we now call the Yamnaya swept out of that steppe in one of the largest migrations in human prehistory. When David Reich, Wolfgang Hack, and their colleagues sequenced dozens of ancient genomes and published the results in 2015, they showed just how enormous the movement had been. A wave of steppe ancestry that poured west into Europe and reshaped the genetic makeup of nearly the entire continent. The Yamnaya were pastoralists. They had tamed the horse and built wheeled carts, and that mobility let them spread in every direction at once. Wherever they went, they carried their genes with them, and among those genes, in significant numbers, was the switch for blue eyes. To the west, they flowed into Europe, and the trait concentrated there over the following millennia, not because it started in the north, but because the populations carrying it eventually settled there in dense, relatively isolated communities where the gene had room to build up. That is the quiet correction at the heart of this whole story. Blue eyes are common in the north today, not because they were born there, but because that is where the tide happened to pool. But the same tide also ran east. And that is the part most people in the West have simply never heard. The descendants of those steppe populations did not only move toward Europe, they pushed the other way too. Across the mountains of Central Asia, down into the high deserts of what is now Western China. And the genetic traces of that ancient movement are still visible today in living people thousands of kilometers from any European city. In the high valleys of the Pamir Mountains, where Tajikistan, Afghanistan, Pakistan, and China all press up against one another, there are communities where blue eyes surface with surprising regularity. The Pamiri, the Wakhi, in isolated Hazara villages. Their DNA carries strong signals from the same ancient steppe ancestry that gave Europe its pale eyes. Among the Uyghurs of Xinjiang, whose genomes blend European, Central Asian, and East Asian ancestry going back thousands of years, blue eyes appear here and there. A Uyghur child in Kashgar with eyes that look as though they belong somewhere in Scandinavia. And beneath the sand of that same region lies some of the strangest bodies in all of archaeology. In the Tarim Basin, in the Taklamakan Desert, hundreds of naturally mummified people have been pulled from the dry ground. Some of them nearly 4,000 years old, their fair and reddish hair still preserved by the arid air, their features unlike the people who live around them now. For decades, they fueled wild theories, lost Europeans who had somehow wandered thousands of kilometers east. But when their DNA was finally sequenced and published in Nature in 2021, the answer was quieter and far more interesting. The Tarim mummies were not European migrants at all. They were a deeply local population, direct descendants of an ancient Ice Age people geneticists call the ancient North Eurasians, the same deep root that also fed into the steppe world further west. They had not traveled to meet Europe. They and Europe simply shared a very old grandparent. Their light features were not an import. They were an inheritance from a world older than either continent. One population makes the point sharper than any other. In the remote valleys of the Hindu Kush in northern Pakistan live the Kalash. Only a few thousand people left, speaking an ancient Indo-European language and keeping pre-Islamic traditions. Many have light skin, fair hair, and pale eyes, and for centuries the romantic story was that they descended from the lost soldiers of Alexander the Great. But when Qasim Ayub and colleagues studied their genetics closely and published in 2015, the truth turned out to be older and less cinematic. The Kalash are not the children of a Greek army. They are a small, long isolated population who held on to deep ancient ancestry that the rest of the world blended away. A living fragment of a far older Eurasian world. That is the recurring shape of it. Wall a community off behind mountain passes and rushing rivers, have people marry mostly within the group for century after century, and a rare trait that arrived long ago stops fading and starts concentrating instead. These isolated valleys became accidental archives, preserving a slice of ancient ancestry the busier, better-connected world washed out. And when you lay it all out, the map of blue eyes stops looking like a national or racial border and starts looking like something else, a record of movement. A faded map of where people walked and traded and mixed and married over thousands of years. Think about what it takes for a single mutation to reach nearly 500 million people. Every modern blue-eyed person carries an unbroken line of descent back to that one original ancestor. If you trace any family tree back 200 generations, you very quickly hit a strange arithmetic. In theory, you would have more ancestors than there were people alive on Earth at the time. Which can only mean one thing. The same individuals appear in your family tree over and over from countless different angles. The blue-eyed ancestor is one of those repeating figures. Not one of your forebears once, one of your forebears thousands of times over, their signature folded back into your bloodline through more paths than anyone could ever draw. Why did it spread at all? That part is still genuinely debated, and honesty matters here. Blue eyes offer no obvious survival advantage. They do not fend off disease or cold or sun. If anything, a low pigment iris handles bright light slightly worse. So scientists have argued for years. Some think blue eyes were simply attractive in the small, tight-knit populations of post-Ice Age Eurasia, a novelty that got noticed, remembered, and passed on. Others suspect the mutation rode along beside some other useful trait, and it was that neighbor being selected, not the eye color itself. Still others think it was plain luck, genetic drift, a harmless quirk carried along by populations that happened to grow fast. We may never know for certain. What we do know is the outcome. It spread, and it kept spreading, until it reached every corner of Eurasia where people moved. So let's bring all of this back to you. If you are watching this with blue eyes of your own, what does it actually mean? It means you are carrying something genuinely ancient, older than any surname you know, older than any photograph, older than any country on any modern map. Somewhere in your line, further back than memory reaches, one ancestor was born with that dim switch in the melanin factory, and against staggering odds, it survived. It made it through thousands of years of chance, through countless generations where it could simply have blinked out and disappeared. Every blue-eyed person alive is proof that it didn't. This is also why a spit-in-a-tube ancestry test can feel a little thin once you know the deeper story. It is not hiding anything from you. It is simply answering a different question. A test like that is built to estimate your recent regional mix, the last few hundred years of your family, and hand it back as a neat pie chart of tidy percentages. It was never designed to trace where a single trait came from. So it might flag some European ancestry and stop there, never once mentioning that the exact same blue-eye switch is sitting in mountain villages thousands of kilometers to the east, or that it began with one person on the edge of Eurasia long before Europe was even a meaningful word. The percentages are just the surface. The real inheritance is the story buried underneath them, and that is the part almost no test ever tells you. And here is the part that ties it together, the part that surprises almost everyone. That mutation does not care about the borders we care about. It does not ask whether your family is European, Central Asian, Middle Eastern, or some blend of all three. The exact same tiny switch shows up in a Danish fishing village and in a Pamiri mountain hamlet, in Ireland and in Afghanistan, in a Kailash valley and on the Irish coast. A blue-eyed woman in the Hindu Kush and a blue-eyed man in rural Ireland are, in a plain and literal sense, distant cousins, both carrying a gift from the same forgotten ancestor. Blue eyes are one of the clearest reminders we have that the neat categories we use to divide people are much younger and much shallower than the DNA underneath them. Under the skin, we are far more tangled together than we tend to admit. The trait that mythology once tried to hand to a single pure lineage turns out to belong to no one people at all. It began in a dark-skinned hunter-gatherer on an open plain, and it scattered across a continent, indifferent to every line we would later draw on the map. There is one last strangeness worth sitting with. For much of the ancient world, the color blue itself was almost impossibly rare, and treated as something close to sacred. There was no bright blue in nature to reach for. The Sumerians and Egyptians prized lapis lazuli so highly that they hauled it thousands of kilometers out of the mountains of Afghanistan just to grind it into pigment for the eyes of their gods. Stranger still, many ancient languages had no distinct word for blue at all, ancient Greek among them, which is part of why Homer could describe a wine-dark sea. Against a world that could barely name the color, imagine encountering a living human being whose eyes held it. To the people who first met them, blue-eyed strangers must have seemed to belong to some other order of things entirely, carrying, in their faces, a color the world had almost no words for. The next time you look into a pair of blue eyes, anywhere in the world, remember what you are actually seeing. Not a badge, not a border, a fragment of scattered light, and behind it, a thread running back through every ancestor in that person's line to a single child born on the grasslands of Eurasia thousands of years ago. A child whose name is gone, whose face we will never see, who left nothing behind but this, a small, quiet change in the machinery of life, still opening its eyes today in millions of people who will never know they are related. The people of the past are not gone. They live on in the smallest details of the people still here. If this story stayed with you, leave a comment and tell us the eye color that runs in your own family and where your people are from. We love reading them. And if you want more deep dives into the hidden ancestry written inside your own body, subscribe and stay with us. There are many more of these journeys ahead.